If yt is the solution of the differential equation of this, then limit of e raised to the power minus 1 yt is equal to. So differential equation which one is given to us is y double prime plus 4y is equal to 2 e raised to the power t. First we will find the complementary function, and right hand side is not 0, is the function of t. So we will find also particular integral and general solution. GS means general solution will be CF complementary function plus the particular integral. That will be the general solution. So first we are going to find a complementary function. To find complementary function, we are going to write auxiliary equation for this differential equation in terms of m. So m square plus 4, this is the auxiliary equation, and roots of this auxiliary equation are means m is plus minus 2i, means purely imaginary roots. So complementary function will be c1 cos, because of value of beta is 2, so 2t in terms of t, because differential equation independent variable of this differential equation is t, so c2 sine 2t. This is the complementary function. Now find a particular integral for this differential equation. So particular integral will be 1 upon fd, and right hand side, this is right hand side, it is it is of the type e raised to the power ax, or in terms of t you can understand e raised to the power et. So write this t e raised to the power t, and value of a is 1 here, because this is e raised to the power a type at, and value of a is 1. So replace this a, replace d by a if fd, sorry, fa is not equal to 0. So what is fd? Fd is d square plus 4, and replace d by a, value of f1 will be, or fa will be 1 square plus 4, this is 5, so which is not equal to 0. So you can replace this one is equal to 2, because 2 is also in right hand side. So 2 upon fa is 5 e raised to the power t. This is our particular integral. So how to write a particular integral? First write, if you can say this is the function of t, or sometimes you can say x, or sometimes you can say t, if this is respective variable in either x or t. So write 1 upon fd, 1 upon fd, and if it is in terms of x, so this one is equal to 1 upon fd e raised to the power ax, because x is of the type ax, and you can write this as f a, if f a and e raised to the power ax, where fa is not equal to 0. So this is the way to write a particular integral. So now we have particular integral complementary function. So general solution will be y. You can say y is c1 cos 2t plus c2 sine 2t plus complementary function 2 upon 5 e raised to the power t. And we have to find the limiting value as n tends to infinity e raised to the power minus t y, or yt, because this is the function of t. So you can write yt. So it will be, this expression will be limit n tends to infinity, or you can say, because this is in t, so t tends to infinity, and this one will be c1 e raised to the power minus t cos 2t plus c2 e raised to the power minus t sin 2t plus 2 upon 5. So as n tends to n or t tends to infinity, e raised to the power minus t will go to 0. How? You can say by graph, because e raised to the power x this is the graph of e raised to the power x, and this is the graph of e raised to the power minus x. As you are approaching to infinity, e raised to the power minus x is going to be 0. So you can see here. So value of this one is equal to 2 upon 5, because this term will go to 0. This one is also 0. And this is finally we have left. So limit t tends to infinity e raised to the power, means the limit t tends to infinity e raised to the power minus t y is equal to 2 upon 5. Now check which one option is giving 2 upon 5. Option B is correct.